So this one is on sequences and series. We're starting off with a hard question that actually combines the last lesson or the last review on exponential formulas and this review, which is on sequences and series. So the first thing we see is we want a recursive definition that models the growth of a one-time investment of $6,000 in a bank account with a yearly interest rate of 3% compounded monthly. So the first weird thing I noticed, usually we have a sub 1 for recursion. Technically you can call it a sub 0. This is directly from Regents and that's what they did. So we're starting out with 6,000. We're getting a yearly interest rate of 3% compounded monthly. So if it's compounded monthly, we're thinking of this formula. P times 1 plus R over N to the NT. So the ones that kind of look like they're in that form is really only number 1. So let's look at it more. It's different because we're with a sequence formula. If we're compounding monthly, the value of N does have to be 12, which we see here. Now the value of N is 12 also here, but that's not written as a decimal as 0.03. So I don't think it's that one. This shows compounded continuously. This shows a basic growth. Now what's weird here is instead of a P, we're taking the term before it, which is how recursion works. And we don't have a T, but this is building each year with recursion, like we're predicting the next year based on the last year. So that all makes sense. So it is choice number 1. Next one, according to the College Board, the average cost of tuition and fees for the 2016 school year was $33,480 at private colleges. This average cost is projected to increase at a rate of 3.5% annually. Assuming the rate of increase is maintained for several years, which equations can be used to predict the average cost of tuition and fees for private colleges n years after 2015. So we want any formulas that work, and we notice that some of them, like 1 and 3, are explicit formulas, and 3 and 4 are recursive. Now, what's happening here, first off, is that we're multiplying by 1.035. That's our base if we're increasing by 3.5% annually. There's no compounding on this one. Now we know for an explicit formula, we typically write it as a sub 1 times b to the n minus 1. So number 2 looks good for that. So we're doing years after 2015. Let's just check that. So 2016 would be year number 1, which is how I want it to work to use an a sub 1. So number 2 looks good. With recursion, we're going to say what we start with, which looks good for 3 and 4. And then we want to say to get the next year, we take the last year and we multiply it by this number because it's a multiplying pattern if it's increasing exponentially or by percents. So number 4 looks good for that. This has a little extra going on. We don't need to write this. That's going to get plugged in for the C sub n minus 1. So that one's not correct. This one shows almost the right formula. It's explicit, but it doesn't have the n minus 1. So the next one says David is a landowner is leasing some land to a popular cell phone company to build a cell phone tower. The company pays David $8,400 for the first year, and each year the payments increase by 3%. Which expression can help David calculate the total amount of money the cell phone company will pay him over the 20 years of the lease? So we see 2 things here. We see some summations with sigma, which are a way to add things up. And then we also see some that look similar to that S sub n formula. So I'm just going to write that down. We have a sub 1 minus a sub 1 times r to the n minus 1 over 1 minus r. And that is given to you on the reference sheet. You just have to know to look it up. So I'm actually going to check those 2 first. So the a sub 1 looks good in both of them. We're starting with 8,400. This one is not right, because even though the formula says R, we know we have to change it to a B. And if we're increasing by 3%, we need a 1.03 there. And that was wrong by me. This should be B to the N, not B to the N minus 1. Sorry about that. This one does look good. Let's just check the 1 minus R, or 1 minus B in this case. So this should be 1 minus 1.03. And that's something we'll talk about in class. The formula sheet that you get for the Regent says R here, and we have to automatically know to replace it with B. Okay, so looking at this, there's our formula. That doesn't have, this would be negative 0.03, so that's also not correct. Moving up to the sigmas, We want to sum from the 1st to 20th year, so that looks good. That's what we start with and the year we end. We want to use our a sub n formula, which is a sub 1 times b to the n minus 1 next to the sigma, which looks like here, except we're using the variable k. So that is choice 2. The next one says the 8th and 10th terms of a sequence are 100 and 144. The sequence is either arithmetic or geometric. Which one of these cannot be the 9th term? So first off, if I think of an adding pattern, this number would have to be 122 because we'd be going up by 22 each time. If I was thinking of a multiplying pattern, if I put 120 in here, so this is just trying choice 3, I'm kind of going in the order I would probably try them. Then if I do 120 divided by 100 and 144 divided by 120, that would give me a multiplier of 1.2. So that would work. So we want the one that doesn't work. Negative 120 would give me a multiplier of negative 1.2. With the adding pattern, which is where the 122 comes from, there's no way I can bounce into the negatives and back into the positives though. So this is the one that it cannot be. The next one says, which of the following formula is equivalent to the geometric series modeled by this equation? So here we have an explicit formula. Going from explicit to recursive, it's good to write out terms. So my first term, 5 times 2 to the 1 minus 1, that's 5 times 2 to the 0, so that's 5 times 1 is 5. A sub 2 is 5 times 2 to the 2 minus 1, 5 times 2 to the first is 10, and then we have 5 times 2 to the 3 minus 1, so that's 20. So we want a sequence that goes 5, 10, 20. See my recursive sequences, we want our a sub 1 to be 5, so I'm going to cross out these two. And to get to the next term, we're multiplying by 2. Now, this one has it set up a little differently. We see the n and the n plus 1. Usually we see n minus 1 and n here in those locations, but we know that means the same thing. It just means to get the next term, take the term before it. So that's choice 1.